MapReduce, since you already know all the terminology, I would not probably spend time in explaining that, right? But I would still want to cover the high level funda about that, right? The architecture part of it. So let me just quickly do that. Okay, so assuming that you know this, but let us spend only 10 minutes or 15 minutes of time here. So let's say I have a master-slave architecture. Since Hadoop works on a master-slave architecture, right? I'm just taking a real-world scenario just to understand what is MapReduce, how it works. Okay, so let's say you take an example of any company. All right, you have any team where you have managers and developers working as a team, correct? So basically I'm going to help you understand how MapReduce is designed, what principle it follows, right? And we are just taking a real world practical example just to understand that first. So let's say you have a manager and one developer in a team, right? This is a manager, this is, let's say, a developer in a team, and there are only two people in the team. Now let's say there is a project requirement that comes to you where manager has to basically develop some hands-on project. So what he does, let's say that project would probably take about a 4 months time, okay? Assuming that the requirements and everything is gathered and they have done this analysis, it takes about 4 months time. So if he has only one developer, right, obviously managers don't work, we know that. So obviously the developer has to do all the job, and in that case only one developer will take 4 months to complete this work, right? Now instead of that, if the manager hires 4 different developers, right? So you have developer 1, developer 2, developer 3 and developer 4. Okay, so if you have 4 developers, now if he can divide this work among 4 developers, right? So I'll just say work 1 is being given to developer 1, work 2, work 3 and work 4. Okay, so basically he has just divided the entire project into 4 parts and given to the different developers. Now once this work has been assigned to different developers, obviously assuming that the skills and the knowledge and the efficiency of all the developers are same, in that case all of them can parallelly complete this work, right? And that would be 1 month, right? In 1 month they can complete this work. Each one of them can, let's say, generate that intermediate output, output 1, output 2, output 3 and output 4, right? So once you have the intermediate output generated, after that what manager can do is he can actually still you have not yet solved the entire project, right? We have we wanted to basically complete the entire project by integrating this output, right? So what manager thinks is, okay, let me ask one of my senior developer to do this integration job. So let's say he assigns this work of integration to developer 2, he may be a senior developer. He will take up all this work, right? Aggregate the output, and probably final output, whatever he generates, it may be given to the client or stored in some storage system, right? So that's how typically high level any team would work, right? So what we have done here is, we got the big project, we have divided that work into smaller problems, smaller parts. That big problem is divided into smaller problems, and each smaller problem is allocated to different individuals to work on that. Now since we have allocated it to different individuals and they are not dependent on each other, they can parallelly work on solving that smaller problems, and that is what has happened here. They have generated the intermediate output, and then finally they have combined the output and generated a final output, and that is what we can ship it to the client, right? So what we have done is something called divide and conquer strategy, right? We have first divided the bigger problem into smaller chunks, and then we have basically solved them parallelly in a distributed way, and then we have just combined the output, right? So this principle is used, and the entire, by the way, this principle is called divide and conquer, and this principle is used in MapReduce framework. So this entire process that we have understood is called MapReduce framework, right? And I'm sure you know this, but I just wanted to quickly set the expectation that this is how the MapReduce works. And here I have just taken the real world example of manager and developer so that we can easily relate that, right? Now I will take it to the more technical level. Now we will discuss about the architecture of MapReduce so we can easily understand it. Okay, so do you agree with me? So you want me to skip the entire architecture? Okay, great. Okay, cool. So let us do that. So here is the, so since you already know that, let us start talking about the Hadoop 2.0 and the Yarn architecture. So I'll first cover the problems with Hadoop 1.0, right? And why those, once you understand the problem, you can better appreciate, okay, what are the enhancements that are done as part of Hadoop 2.0, right? And then we get into the Hadoop 2.0 cluster architecture. We understand Yarn, which is called yet another resource negotiator, right? That's where we understand the entire architecture of Yarn and how a MapReduce job gets executed into the Yarn. Okay, so let us start that. So what were the problems in Hadoop 1.0? So if you see here, the problems were, the first problem was name node, no horizontal scalability, right? Since you know about Hadoop 1.0, there was a master-slave architecture where master process is called name node and slave processes are called data nodes, right? If you see like this, these are called data nodes. But there was always only single name node available, which is called the master node. You have a secondary name node, but it is not a backup of the name node. So in case if the name node fails, which is actually keeping all the metadata information in memory, if the name node fails, then you don't have any backup node available, and then entire cluster is unavailable, entire cluster is unreachable, even if the single process fails. That is why it is called no high availability. And and also it covers no horizontal scalability, because in Hadoop 1.0 it does not have a support where I can add one more name node and I can call him as a backup name node, and which can be integrated like this. Okay, it is not possible. Hadoop 1.0 framework was not having that flexibility to add one more name node in this architecture. That is why it is called no horizontal scalability. So the single name node, single namespace, unlimited by name node RAM, and since you have no high availability, it is called single point of failure. So if name node fails, you need to, the entire cluster is unavailable, you need to restart it, then you need to do the manual recovery using secondary name node. For loading all the metadata information, you need to restart the name node, and then again it would start serving the cluster. So basically that's the bigger problem we wanted to solve. That is one big issue. Another issue is called job tracker overburden, which means since you know already the architecture of MapReduce, if I have to draw this again, you have single job tracker and multiple task trackers, right? This is your job tracker, these are multiple task trackers. Now once you assign, let's say if I run 100 MapReduce programs on this cluster, all the 100 MapReduce programs will be converted into mappers and reducers, right? You may have map 1, map 2, map 3. All the mappers are running here. You may have reducer 1 running here. You may have reducer 2 running here. And again, all the map reduce jobs will be converted into different mappers and reducers. So there is only single process called job tracker who is managing the entire life cycle of all the map reduce programs, right? He is the one who has to decide how many mappers to be created, which mapper should be assigned to which task tracker, and stuff like that, right? And also manage everything. So what we were discussing is basically, since you have a job tracker and different task trackers, right? And since the same job tracker was handling the load of managing all the different MapReduce programs, he also needs to make sure that all the mappers of the same MapReduce programs gets executed successfully. If one of the mapper fails, he also needs to take care of the failures, right? To make sure if the one mapper fails here, he will go and assigns the execution of the same mapper to some other task tracker wherever the same data block exists. And that way the failure also has to be managed. And the same case with the task tracker failure. If one of the task tracker fails, then also job tracker has to handle that failure accordingly, right? So a lot of activities were given to only single process, and that is why we can safely say that our job tracker was overburdened. Okay, and that is what I'm going to that is what I'm emphasizing here. So basically, job tracker was overburdened, spent significant portion of the time and effort managing the life cycle of applications, right? Now that was another issue. After that, one more issue, if you notice, Hadoop 1.0 will give you, basically Hadoop framework will give you two important features. One is to store the data in a distributed manner, right? And once you store it in a distributed manner, you can also process it in a distributed manner. Okay, so storage part is covered using HDFS and the processing part is covered using MapReduce. But if you see here in Hadoop 1.0, it always mandates you to write MapReduce program if you want to process data which is stored on the Hadoop framework, right? Which means only mappers and reduce tasks were allowed, right? Even if you, let's say, want to kind of basically write Hive query or pig scripts, since you know that it would automatically convert that into the MapReduce programs and then execute it as a MapReduce program. So ultimately, everything that you execute, you process on the data which is stored on Hadoop 1.0 cluster will definitely have to be converted as a MapReduce, and then only you can process the data. So that is kind of a limitation. Only map and reduce tasks are allowed. But what if, let's say, you have already designed a beautiful framework which allows you to store data in a distributed manner? Can we not leverage the, power of different types of processing techniques rather than just relying on only MapReduce technique? That was the issue, I would say the limitation that people thought, and in fact Yahoo is the one who developed the Yarn framework, and they were the one who identified these problems initially. So they thought, let us do something, let us try to build a framework which allows you to execute not only MapReduce but any type of distributed processing tech programs on the Hadoop cluster. Right, so we will understand now the solution for all these problems. So these are the four problems which are, I would say, a key problems which were existed in Hadoop 1.0, and that is where there was a need to develop Hadoop 2.0 version which could have the features which can solve these issues. Right, so did you understand the problems with Hadoop 1.0? Do you have any questions here? All right, great. So let us move forward. So these are just a pictorial representation of what we wanted to understand, like name node, no high availability and no scalability. You already understand this, right? So one name node goes down, you don't have any backup name node, and hence the entire cluster goes down, right? And then you have job tracker overburden, then you have unutilized data in HDFS because you are allowed to execute only using MapReduce programs. So before we get into the solution piece and understand the yarn, we also cover the cluster architecture. So now in Hadoop 2.0, this is how your overall cluster looks like, right? So since I told you that Hadoop basically gives you the storage part handled by SDFS, and the processing part now in Hadoop 2.0 is handled by Yarn. So that's why there are two branches, right? If you see here. Okay, so there are two branches, and basically what we need to do is we are basically trying to, so what happens here is you have these two branches, one is SDFS, another one is Yarn, and in SDFS you can see now we don't have only single name node, but we have multiple name nodes. So there is an active name node, right, and there is a standby name node. Okay, earlier we used to have only active name node available. There was definitely secondary name node, and I'm assuming that you understand that these processes were useful in doing the checkpointing, right, and periodically making sure that the metadata information gets up to date and stored in the physical file system. But apart from that, now you are also bringing one more name node called standby name node. Now, having said that, don't assume that it is just two name nodes. You can have as many number of name nodes as you want in Hadoop 2.0 cluster, right? So it depends on the requirement and the configurations. Now, if you see here, all these two processes are interconnected. That means all the data nodes are connected to both the name nodes. Assuming that there are only two name nodes in this architecture, all the data nodes that are available both are connected to active as well as standby name node, right? And similarly, active and standby name node both are actually storing their metadata information in a shared, basically they use a shared edit logs and metadata information, so that they both will have a up-to-date information, metadata information about the entire cluster, right? So in case if active name node goes down, you still have someone as a backup who already have the knowledge about the cluster, and it can directly fail over to the standby name node, and it can start serving the cluster because it already knows the metadata information. And that is the important change that has been brought into to make sure that the name node high availability is there, and you will never have a single point of failure. So that is one major change with respect to SDFS, and people call it SDFS 2.0 also. With respect to Yarn, which is about processing of the data, processing framework, right? So earlier there was MapReduce. Some people call it as next generation MapReduce, but it is basically, you know, the next generation of, I would say, processing framework, not the MapReduce framework. Why? Because it allows you to write distributed processing programs in languages other than MapReduce, not only MapReduce. Okay, we will understand more in detail about this architecture in going forward, right? So right now let us just assume that there is something called Yarn, which is basically an enhancement to the existing MapReduce framework, right? So this is how the cluster architecture looks like. So let us now move forward to the Yarn part, which is the most interesting part, and we wanted to cover that in detail. So basically, if you can see from this diagram, what you can see here is you have SDFS, which takes care of the data, right? Now it is SDFS 2. You have Yarn, which is a middle layer, which basically converts all your queries and, you know, APIs and programs, all the distributed processing programs into its own native framework, and then execute it distributedly on the SDFS where the data is stored. But here, if you can see, you can execute MapReduce programs the way you used to execute it on your Hadoop 1.0 framework. Also, you can execute edge-based queries, the storm queries, giraffe algorithms. These are called graph theory algorithms. Spark, one of the most I would say a hot keyword, hot buzzword these days in the market, which is called in-memory MapReduce programs, okay, which is X times faster than existing MapReduce programs, okay. And you have all the lot of other distributed programs supporting, right? So Yarn, having Yarn on Hadoop 2.0 can abstract out all the complexities where you are not now. It is not mandatory for you to convert everything into MapReduce. You just write a map distributed programs which can be supported by Yarn. That's it. Now Yarn will take care of converting it into the native format and then execute it. Okay, so this is how a high level cluster looks like using Yarn. So now let us try to understand it more in detail about Yarn architecture. Okay, so I'll take it the architecture. I'll basically explain each and every process in detail. But before I move forward, do you have any question, Vikram, or you understood whatever I have explained so far? Let me talk about some of the processes in Yarn. Okay, so very similar. I'll just draw architecture first in a very native format. So basically you have a master node, you have slave nodes. Okay, the master node now is called resource manager. Okay, and the slave nodes are called node managers. So basically master node will have resource manager as well as name node running in the same machine, or they may be running in a different machine. So it is again a configurable configuration issue, and admin can configure it differently. If he has different machines available, he can do it differently. Otherwise both these master process can run under the same machine. Okay, now node manager is part of one of the slave nodes, where what happens is, what we were discussing is same architecture now gets converted using a master slave. So it's basically you have so what I was telling is basically you have a resource manager or name node which can be part of the master node itself, and you have a node manager now which is part of the slave node. So now each slave node will have node manager as well as data node running, each of the slave node. Okay, now I'll explain you what does a resource manager do and what does a node manager do. We will get into that part little later. Apart from that, they both will apart from that, there is also one more process which is important, which is called application master. Okay, and this process is not pre-configured, or it's not always running. It will be running as and when you execute a MapReduce program. So I'll explain you what does that mean and what purpose does it solve. Okay, so this is how the cluster looks like. So instead of your job tracker, now you have resource manager. Instead of task tracker, you have node managers, and you can have multiple resource manager, not like the Hadoop 1.0 where you can have only single task tracker. Okay, so before I get into the Yarn part, I just wanted to tell you something. There is an architecture that we are going to understand. Okay, so before we understand this part, I would basically help you understand what all technologies that you need to what all processes that you need to understand, and how each processes will be playing a role in executing a MapReduce job. So I'll be basically using this diagram to talk about the entire architecture, but in the subsequent slides we have divided the entire execution into different phases. So if you can see, there are multiple phases. Like first phase is called job submission, then you have job initialization, then you have task assignment, task execution, progress and status updates, job completion, lot of things. Okay, so I'm basically doing that, but I would not go on those slides. What I will do is, to explain each and every phase, I will just refer this architecture. Okay, and we will talk about it in detail. So let us first understand the high-level processes. You have a client who submits the MapReduce job. We understand that, right? Now you have Yarn Resource Manager, which coordinates the allocation of compute resources on the cluster. Then you have Node Manager, which launch and monitors the compute resources on machines in the cluster, right? Then you have a MapReduce application master, right, which coordinates the task running the MapReduce job. The application master basically so what happens is you need to just think it this way. There is always one application master for one MapReduce job that you are executing. Okay, so if you have 100 MapReduce programs executed on your cluster, you have 100 application masters. What I wanted to say is we have basically the Yarn processes, and I was explaining application master, where application master is basically dedicated to each MapReduce job. Unlike your Hadoop 1.0 framework, where even if you execute 100 MapReduce job, you will have only single job tracker who manages everything, resource allocation as well as execution of the mapper and reducer task. So here you have dedicated application masters. That way we are dividing the load, right, and giving it to different processes. And once the MapReduce program gets executed successfully and gets completed successfully, that particular application master will be stopped or will be killed. Okay, so that will be managed by resource manager. So let us go and understand in more detail about what each process does. Resource manager will actually take care of, it's a global resource manager. So what it does is, it's basically once you submit a MapReduce job, from that point onwards, allocating the resources to different map tasks and reduce tasks will be decided by resource manager. Okay, and also it will decide which node I should create application master, because application master also, remember, is a process, and that process needs, when you want to execute any process, it needs a resources like CPU, processing power, RAM, memory, everything. So that's where resource manager will assign that resources to the application master to make sure that, okay, please execute this application master in this particular container. Okay, so container is basically nothing but you have a environment where dedicated resources, memory, CPU power, everything is allocated, so that whatever you execute inside this container can have only that much resources, can only utilize that much resources, right? And that's why you have a better segregation in terms of resources, so that one process, even if it is taking too much time to complete, it can only utilize the resources which are given to that process, right? It cannot eat up the resources which are given to any other process. Right? So that's why you have better resource management in place, and the entire thing is controlled by your global resource manager. Now there is another process called Node Manager, which I have just explained, which is basically running on each and every slave node. Now what does Node Manager do? Node Manager is basically managing the life cycle of the container which are allocated by resource manager. Okay, so we will actually get into the diagram and understand it in better clarity. So let me take up the diagram so it will be more clearer to us. So let's say resource manager, what it does, first gives, resource manager, what it does, first it actually gives the resources to the node managers, right? So let me show you this so it will be more clear. Let me open another a blank sheet, and we will understand it in a diagram wise. So I'll just have, let's say, 3 processes. You have one, you have another one. Okay, so this is our resource manager, and these are all node managers. Okay, now let's say when client submits a MapReduce program, what happens is this MapReduce program for this MapReduce program, resource manager will not decide how many map tasks and reduce tasks that needs to get executed. It will not even do anything of that sort. What it will do, whatever program that gets submitted, it will just first allocate the resources to the node manager in one of the slave node. That okay, let's say this is the container. When I say container, it is basically nothing but an environment where dedicated resources are configured, and it will command to the node manager saying that okay, please execute this MapReduce job using a process which should be running in this particular container, right? So it will first allocate the container to node manager and also tell him to start application master. So node manager is the one which will basically launch these processes. So always remember this way, resource manager will tell node manager, this is the resources, these are the resources you have, now you need to execute this process. That's it. Node manager will basically launch this and execute it within that container and make sure everything is going smooth within that container. Right, so it manages, node manager is just like a local resource manager for that particular node, and resource manager is a global resource manager for all the nodes. Okay, so here once the container is allocated, node manager will launch application master within this container. Now why application master is launched? Because there will be dedicated application master for each and every MapReduce that we execute. Okay, so application master is running here. After that, right, so this container will have its own CPU, RAM, everything where this application master is running. Now after that, it's application master's job to execute this entire MapReduce job. Okay, so application master will again look based on the metadata information in SDFS, right? It will basically look that okay, how many input splits are there for this MapReduce, and based on that it finds out okay, I have to create 3 mappers, assuming that let's say I have to create 3 map tasks for this MapReduce job. So it will again go to resource manager and ask him, can you please give me the containers where I can launch this map task. When I say container, again it is nothing but resources which has CPU, RAM, processing power, capacity. Resource manager will give him that, and based on that, let's say assume that it will launch this map task in different containers. So let's say there is a container 1 which has map 1, there is a container 2 which has map 2. Okay, and maybe here there is another container which will be having map 3. Okay, now entire execution of map tasks will be controlled by the same application master. Okay, so he is the one who is making sure that if there is one map task failed, do I need to relaunch it to the same node or to some other node where the replica copy of the data block available? All these failures are taken care by MapReduce job level failures are taken care by application master. Right? Once these mappers are executed, it will again go to the resource manager for asking a container to launch reduce task. Once it gets that, it will actually launch this to the, let's say reduce task is launched to one of the node in that container. Okay, and then the entire MapReduce, once it gets completed and the output is stored in the SDFS, then resource manager would free up the resources which were allocated to these processes, and it will also free up entire application master. Right? So this is how high level the MapReduce job gets executed. Okay, now the beautiful part of this framework is it is not only map task or reduce task, but if you let's say execute a Spark program, okay, or if you execute for that matter any other distributed processing program, you will have a dedicated Spark application master, or that particular processing application master will be created, and it will know how to execute that particular process. And basically it will just go and talk to resource manager that give me the container or resources for this process. It will give him, and then it will launch it to the different nodes. Right? So there is a support available for all these different distributed processing framework in Yarn itself. Right? They have a dedicated application master created, and they will know how to execute them. Okay, so this is how the entire Yarn framework is developed. Okay, so now let us now understand little bit in more detail about this. So what happens is, if you see, you have different phases for MapReduce job execution, right? So what happens here is, let's say you want to execute a MapReduce job. So first you have a client node where first phase is job submission. So you have a MapReduce program, the client node submits it, right, via job object. You have a job object in your MapReduce program. You will say job.submit. It will go to the resource manager. First, it will get the application ID from resource manager. Now in Yarn, remember that in Hadoop 1.0, by the way, we used to call each MapReduce job as job, right? We used to call multiple jobs and there will be job ID allocated to different MapReduce programs. But in case of Yarn, each MapReduce program is called an application and there will be a dedicated application ID attached to it. Okay, so when it goes to the resource manager, it actually gets a new application ID. Okay, after that, the client node will basically check whether the input file is exist in the SDFS and the output directory does not exist in the SDFS, right? All these preliminary checks are done, and it will also calculate the input split and store all the information into SDFS. It is very similar to our earlier architecture, MapReduce architecture, the version 1 architecture. After that, it will submit that application to resource manager. Now once the application is submitted to resource manager will basically start a container. If you remember, right, that's what we understood. So it will allocate this container to any of the node manager, one of the slave node where the node manager is running, and ask him to launch a dedicated application master. So here it is called MR App Master. Basically it's called MapReduce Application Master, and that application master will know how to execute MapReduce job. If you are executing Spark jobs, I mean the program which you have run using Spark framework, then there will be a dedicated Spark application master available which know how to execute it in a Spark way. Okay, so it launches that app master. That's it, done. After that, the app master will basically read the metadata information about that job. It retrieves the input split information about that MapReduce job, and it will find out that, okay, I have to create so many number of mappers, but for that I need a container or resources. So let me again go to resource manager and ask him about the containers. It will go there and then it will basically get these details. Then it will start this container in one of the slave nodes where it will launch a Yarn child which may be a map task or a reduce task. Okay, and likewise all the tasks will be completed, and then finally it will be, the output will be sent back to the resource manager. It will be sent back to the client saying that, okay, your MapReduce job is completed, and finally resource manager will release all the resources from this containers. Okay, so app masters again will be freed up, will be killed when your MapReduce job is successfully completed. After that, when you execute launch another MapReduce job, there will be another application master which is getting created. Okay, so these are about happy path scenario, and we understand how internally MapReduce job gets executed using Yarn framework. Okay, so there are different phases. Job submission, we understood that. Job initialization, where resource manager take up that job and assign a particular app master to that job, and also container where it can run. Then you have job execution, which will be taken care by map app master, where it will divide that into map task, reduce task, get the container from resource manager and execute them as a Yarn child. And once that is completed, the final step is called job completion, where all the resources are released and it will notify that to resource manager. Resource manager will notify back to the client. Okay, and then resource manager will also free up the resources of the app master. So this is how entire MapReduce framework gets entire MapReduce job gets executed using yarn architecture. Alright, so now I'll just cover the failure part of this. Basically, what happens if there is any failure? Okay, so the failures are very similar to the version 1, where let's say you have one of the map task or reduce task gets failed, right? And that is the reason why they are launched in a separate JVM, so that even if it fails, the entire process will not be killed, and the app master will identify that okay, this particular map task is failed, so it can actually launch it for another node manager. It can assign it to another node manager where the replica copy of this block available. Let's say block 1 is available here, block 1 is available here. So if this guy fails, it can allocate the same map task, relaunch that map task to another node manager where the same replica copy is available, and it will execute that. Okay, even if one map task is not failed, but if it was taking too much time to execute, right, then also application master can actually launch the same map task to some other node manager where the replica copy of that data block available, just to make sure that if one of the map tasks which was taking too much time to execute, if it finally fails and if it does not execute successfully, then you have a backup map task which was already started. So whichever map task from here and here gets completed first, the output of that map task will be used, and this process is called speculative execution. Okay, that is about a map task or a reduced task level failures. There is a the node manager level failure. What if your node manager itself is failed? So in that case, basically, if the node manager is failed, then there is no one who can actually take control of this process, take control of this container or managing the container. Basically, if node manager fails, there is no one who can take control of executing this task, and that's where also there is no one who can respond back the app master that how much progress that particular task has made, how much percentage it has been completed. And that is where app master, again through heartbeat signal, if it does not get any response from node manager, it will relaunch this map task to another node manager by considering that okay, this particular node manager is failed, and let us not assign any more tasks to this node manager until we hear back from this node manager. Okay, till then it is marked as failed node manager. That is called node manager level failure. Another failure could be the app master failure, which means if the app master who is managing this entire process communication and executing entire MapReduce job, what if that guy itself is failed? In that case, the resource manager periodically will check, and if it does not get a heartbeat signal from app master, it will basically assume that the app master is failed, and hence it will free up the resources allocated to app master as well as all the other resources related to map task and reduce task, right? So that it basically marks that job as a failed job, and it has to be re-executed again. Resource manager will not do it by itself. Client have to again re-execute that job to resubmit that job to the resource manager. So app master fails, then that means the job itself is failed. Okay, so this is how the failures are handled at multiple places. What if the master guy itself failed, which is called resource manager? If the resource manager itself is failed, then in Hadoop 2.0, by the way, you have a option of configuring a backup resource manager. In that case, you can still go ahead and have a backup resource manager which can do this job for you. But unfortunately, if the resource manager fails, the backup resource manager is available, then yes, your jobs are still taken care. But if it is not configured, then again it becomes the single point of failure, and all the MapReduce job or any distributed processing job which are submitted to this resource manager will be basically killed, and you need to resubmit them to the resource manager. Otherwise, it will not be executed. So there is actually there are properties available where you can configure that multiple resource managers. So you have couple of configuration properties available in Yarn. Okay. All right. Thanks, Vikrant. So I hope it was useful to you today's session. So let us meet tomorrow and we'll definitely continue forward. Thank you. Thank you, Vikrant. Have a good day.